my name is James Cabe. I am a cyber GBB for IoT and operational technology, and I'm here with Anthony.
And I'm Anthony Bartolo, Senior Cloud Advocate with Microsoft, and I'm playing the role of learner today in regards to how IT pros can get involved in the security aspect of IoT and OT. So, James, we went through the whole definition in terms of IoT, OT, the planning stages, the whole aspect of understanding the environment and what could occur, what could be detected, and what could even be enhanced in terms of production work in the terms of a plant or warehouse. Now I'm at the portal. Where do I go from here?
Great questions. So once you're in the Azure portal, you'll notice there's a search window at the very, very top. Defender for IoT won't have shown up inside your Azure services deck that you have on the homepage. So you'll have to go looking for it. So you're going to want to type in Defender for, and then Azure Defender for IoT will show up at that point. Unlike a lot of other apps or services or SaaSes within Azure, this one actually has a hybrid methodology where you'll actually have an on-premises version of the software, as well as some stuff that will be available in the cloud if you so choose. So once you've clicked on Defender for IoT, and I'm sure you've gone there now, you'll be met with an onboarding the subscription, start discovering your network, and then the what else section, right? So where would you usually want to get started in something like this? Where would you want to go first? Do you know?
I would like to start at the endpoint. If that's an option in terms of a hybrid implementation, I would like to start protecting it at the endpoint and then work my way back to the gateway.
Excellent. So to that point, since we're going to do a deployment of a physical sensor, once we've got our subscription onboarded, which essentially is you click on the button, you choose the subscription you want to be able to bill to, and then you can see a pricing page at the very top. Now you'll notice that it's free for 30 days. And that's to anybody, whether or not you have a free account or, like a trial account with Azure or anything else. It's still the same for 1,000 committed devices. And that includes if you decide to do it in a hybrid format and send signals or syslog or, basically resultant set of information up from your on-premises version of it into the cloud for further analytics. And we'll talk about the reasons why you'd want to do that here in a moment. So once you've got your subscription onboarded, you then go and click on Set Up a Sensor. It'll take you to a dialog box. And this is where IT security professionals really can sink their teeth into it because you actually have two selections here. You'll see at the very, very top, it'll have Sensor and On-Premises Management Console and then Updates. The only thing you really need to get started, Anthony, is just the sensor. That is it. So to set up a sensor, you can either go and buy a pre-configured appliance, which is one of the options there. It has a contact button, or you can actually just go ahead and download an ISO and set it up yourself on an approved piece of hardware or as a virtual machine running at your site. So there's more instructions there, identifying the required appliances, how to install the software, and setting up your network to be able to deploy this thing if you decide to deploy it. Now, here's where we come to the crux of your decision making, right? You're a cybersecurity professional at your site. You want to see what's going on because you might have had an incident or you have some sort of audit coming up that you're concerned about, and probably not unduly so. What are the usual objections you're going to run into with management? What have you heard before from management about, these sorts of things? Some hurdles to come over, if you can share with me.
The biggest thing is anything that you're adding to an environment, there's concerns about latency, there's concerns about costs, there's concerns about reliability. They don't want the plant to be down. They want it to be running efficiently, running within its cost that had been budgeted for it. They don't want to add any complexity to the plant. They want to make sure that it continues moving forward.
Great. Now, that's great commentary. So one of the first things to note is that when you deploy this thing at the site, it is going to be 100% passive. It will not interfere in your network. It is only supposed to be a single leg connection to your network over something called a port mirror, which is basically a unidirectional copy of all the traffic going across either a switch or a set of switches up into the sensor. There's nothing coming out of the sensor to cause latency on the network, which would actually upset, if you're dealing with OT systems, one of the biggest problems is some of them even depend on not just NTP or network time protocol, but something called PTP, which is called precision time protocol. And it's something like picosecond or something ridiculous like that, down to that kind of level of precision. So when you're dealing with something like that, you certainly don't want to disturb it with other traffic. So if you really hit a brick wall with that kind of objection that we don't even want to give you a copy of the traffic, you can actually at least then ask them for a PCAP. And this PCAP for maybe 2 days to, you could do it as little as 24 hours, but 2 days to a week is really going to be optimal. Now, you may be concerned with the kind of file sizes that come out of that. But if you're actually on an OT network, what do you want? If I'm getting just an hour's worth of PCAP off a core switch, which would be anywhere between 1 to 10 gigs for an hour's worth of traffic capture, what do you think the file sizes would be for a real OT network?
Would be a lot smaller.
Yeah, why do you think that is?
It's just the data that's being captured is the operation of the device as opposed to the data that's passing through it.
No applications, right? We're still talking about real-time protocols. And so all you're talking about is telemetry being passed, machines talking to other machines. And that's like your video card essentially talking to the processor on your computer, right? There is no application between them. There certainly is no firewall because it has to be real-time. The more you slow down the CPU to graphics card discussion, the slower your graphics go on your computer. It's the same exact thing that happens on one of these real-time or operational technology networks. So when you're getting this traffic capture, an hour's worth of PCAP from an operational technology network can be as little as 768K for an entire hour of PCAP. And that could be maybe 700 devices doing that kind of level of chatting. So these PCAPs are very, very small. Typically, if you're getting a full day of PCAP off of one of those networks, you're going to still be probably under 10 megs of traffic, which is extremely small for most people. So get a hold of that PCAP. This is where it becomes really, really fun. If you have some sort of Hyper-V infrastructure, or if you just have Hyper-V running on a Windows Pro workstation, or you have some other virtualization technology, maybe you're an OSS advocate and you like KVM or Proxmox or something else like that, or you have this big infrastructure that goes to one of the other vendors that does virtualization, you can use any of them, right, with this sort of thing. What you would want to do is you'd install the ISO file that you get on there. Now, there's going to be instructions. They're built in. We're not going to go through all of them and everything. Just know that there are a few gotchas. First, you do not use UEFI BIOS. Secure boot is not supported in this whole thing. If you're using Hyper-V, you are going to use a Gen 1 version of the virtualization format as well, right? So just be aware there's a couple gotchas. You will have to have 2 NICs associated with the device, and you will have to size using the sizing guides, whether it be 2 CPU, 4 vCPU, 4 or 8 gigs of RAM, and the associated disk. The one thing that I will tell you is that you could still thin provision the disk with the appliance if you chose to go virtual. Just understand though that you're going to have to put some reservations in there, at least for 20 to 40 gig, because if you don't, you might find that appliance does not come back to you for whatever reason, because sometimes I am guilty of it myself. I oversubscribe everything in my house because I don't want to pay anything for it. It's all, kind of throwaway stuff, and I'm sure other people will do the same. So just know that those are some of the gotchas. I have mine deployed literally on a NUC, just like this, inside my house. Okay. So, and this actually runs another VM. This thing actually runs Proxmox, which is open source. And on top of that, I run my sensor typically on something that particular size. So it can do anything. I run PCAPs over the top of that, and 2 days where the PCAPs will take you about an hour probably to run through, maybe a little bit longer. And then once you do that, the machine learning engine will start sorting the data and give you this nice little map to go through, right? So your next steps, whether or not you get a PCAP or not, will be to show the efficacy of those results to management, right? So what do you think that's going to look like whenever you do that? So let's talk about success criteria when you start using this sort of thing. What would you want out of a network if you're first discovering what it is and it's been a black box to you?
So I would like a map. I would like to see, in terms of where my data is actually flowing, who has access to what endpoints in terms of the map itself. I'd like to do an exercise of least privilege so that I understand, if there is too much access, how do we restrict that to specific roles that are required? And then I like to show like the threat analysis back to management in terms of the investment that had been put forward, what is now the or before and after of this implementation, and what is the probable cost savings for stopping an attack down the road based on the work and the investment that was put forth by the organization.
Fantastic. So one of the things to note is the sensor automatically breaks up your network and does a mapping of it depending on how it behaves. And it maps directly to something called the Purdue model that we mentioned kind of in the last video. And it does the three layers. It does the operational layer where you usually see the serial protocols and all the electrical stuff, the stuff that operates pumps and actuators and doors and things along those lines. And then it breaks it up to the supervisory section of that, the system. So your DCS or distributed control systems down here, your SCADA systems up here, and then on top you usually have your enterprise stuff, which is Active Directory controllers and file servers and all kinds of DNS stuff and everything else like that, and even the internet way up there that it'll do a bunch of detections with. If you cross more than one of those barriers, so in other words, if you go from the internet straight down to the process control section, you're probably already in trouble. So you're already going to get insights directly from what's going on there. So understanding the behavior and the mapping of the network is something you can get just from a PCAP. You can get all the assets that are talking on it. You can get the CVEs from the assets even. A lot of that stuff, people don't understand the value of a PCAP sometimes in the PII and even IP or intellectual property that's actually contained within packets, right? It's all the information running across the particular network. In OT systems, it's even worse because some of those packets actually contain mixes, right? How much should that mixer put in? How much chemical is pouring into that vat? How much oil do I have to add to that particular system to keep it running at its operational efficiency? All this is collected knowledge over a long period of time, and that's a lot of intellectual property to lose there if you're not taking a look at it. So you can capture all that, and then so you've got a couple of choices. We mentioned the hybridized version where you can keep it offline and dump PCAPs into it. If you deploy it in situ, you will actually get real-time data over a longer period of time, and then you'll be able to run through the first week, which was simulated by the PCAP, of a learning mode, a baselining, right? You can turn off baseline and learning mode even after a full week of being in some of these operational technology networks. You might miss some stuff because there's some stuff in an operational technology network that only fires one time a year, if at all. Some of it only fires if there's a safety issue, right? So some of this stuff may or may not show up depending on how it's architected. You can, after a week, go in and say, hey, this is what we see, but here are the gotchas. Some of this stuff may not fire. We may have to go and collect some of this other data. We may get your firewall rules and dump it into the sensor and figure out what your mitigations are supposed to be and what's supposed to be working and not working. And you can kind of blend that all together after the first week. So that's sort of the perspective you want to take from it. Either PCAP or dump it in the network for a week, let it learn. Second week, turn off the learning. Take a look at the perspectives after that. After 2 weeks, you can go back through and massage all the alarms that you actually see for the particular ecosystem. So, hey, these are alarms we're getting on a normal basis. This is outside the baseline that we originally captured. This is what we see going on. And you'll be able to actually be very consultative about it. At that point in time, you can actually run your first risk assessment. It's a single push button inside the sensor to give you this risk assessment score, right? You go over that risk assessment score, which may take maybe anywhere between, depending on the amount of traffic that's gone through it and the amount of assets we're talking about, it may take anywhere between 30 seconds to, I've even seen it go for an hour, come up with this risk assessment score. Once you go through it, you can actually go, there's a top section of the risk assessment that is actually specifically for CISO level or executive level people that show the amount of what you can do in mitigations, the attached scores, what the suggestions are for actionability, the actions you can take to get a better score. And then that's actually coherent with the down part of the report, which is way at the bottom, which actually contains the punch list for operations people like myself to go through that punch list to do the things that we told the the executives that have to happen, right? So you're getting a coherent report of here's what goes in for leadership, here's what actually happens for the people that actually have to get the work done. So, and it's a coherent report with a bunch of other really good stuff mixed into it. Once you get that risk assessment, you can start making decisions about whether or not you want to either have it cloud connected or not. Now, why would you suppose that we'd want to cloud connect something that's OT that never has been cloud connected before? Can you make a couple guesses or suggestions?
My biggest thing would be for the aspect of efficiency. If I'm taking this device and it's not traditionally connected and I want to connect it to the environment, I want to create a zone as an example to understand how the devices interact with one another. I'd have to connect this device to the hybrid environment to gain that data so that I understand in terms of operation what's the efficient model for that plant.
Yeah, that's a good comment. So what you would do in some of these plants, like nuclear facilities, you have this idea behind a physical air gap. So you're going to have to overcome some of those objections, not to destroy the air gap, but to actually put the on-premises management console. The sensor goes down in field, where you have those in-scope, very, very dangerous kind of equipment that goes right down in there. Then you have a TLS connection to a DMZ for this thing that can then act what they call a data diode. It essentially is a unidirectional gateway that you only can, copy data one direction out of and nothing comes back down into. And that's essentially what that on-premises console or manager is. And you can have a group of sensors reporting up to a single console, and that act as your data diode to get the data out and into the cloud. Now, to do, that functionality goes up into a TLS protocol that you can then lock down into your Azure tenancy using a bunch of different types of technologies, whether that be a express route, whether that be the advanced firewalling, whether that be a bunch of different other things that you can actually put in the way, or even deploy stuff in zero trust architecture to make that happen, that data copy data be extremely secure when it does come up. Once you get it there, Azure Security Center has a bunch of compliancy pieces you can dump things into. We have pre-built Power BI reports for IEC 62443, for NERC CIP, National Energy Regulatory Committee. We've got the same that goes on with the European ISO. We have ISO 27001 reporting. You get the idea. NIST and MITRE ATT&CK frameworks. All of that's actually contained within that particular platform. That's one of the reasons why you pull this data in this cloud, and that's the reason why cloud has been so popular, is because you get this power of many computers that you couldn't even deploy to be able to get results out of that lower level data very, very quickly and make a bunch of different inferences and assumptions, based on that data and the way that you separate it. And that's really the real reason why you do it, so you can actually have this idea of, we went in for just a risk assessment and want to know what we have, what are the vulnerabilities on it, how can people get to it, right? What is its exposure and what are my mitigations? And then that's my risk assessment, right? If I want to pull stuff up there, I can actually get compliances. I can actually get data management, like DLP type results out of it. I can have a constant compliancy score, because one of the biggest fears that people like you and me have is having to sit down with an auditor for a week and get endlessly questioned about this stuff and then have to go and dig up data. What if I can automate that into either Azure Security Center or a set of Power BI reports that go specific to my industry, and then have it automated so I not only know what I've got right now and can show that particular auditor, but I can actually show them 1 month back, 2 months back, and 3 months back. That changes the discussion with any executive board, with any of the executive leadership or anybody inside of a company. It elevates that discussion from technology into how you do business. And that's really one of the most important parts of exactly why I would want to do this, both in a hybrid model into the cloud, pulling the data in the cloud, as well as that risk assessment, because the risk assessment is a very technical discussion. Yes, it's about cybersecurity. Yes, it's very important, but that's just table stakes. I pull it into a hybrid architecture, which is really where I'm headed to, and it elevates the entire discussion up to the executive board. So,
now you made mention of the air gap systems, and I've heard of that terminology before in power plants and what have you, and we did make mention of connecting those systems that are traditionally not connected into the cloud. What is an air gap system? I kind of have an idea, but I want to make sure that I have the terminology down packed. And if cloud or if hybrid is not an option, how do we do the same type of detection in an air-gapped environment?
I made a lot of people clutch pearls or do a pearl clutching thing about 4 or 5 years ago. I was giving a speech at one of these famous cybersecurity conferences, and I said the air gap no longer exists. And some people, I got nodding heads, like, "Oh yeah, you're right." And then other people are like, "Oh, are you kidding? That's impossible. It has to exist. Nuclear facilities, blah blah blah." And I was like, "Well, air gap no longer exists because the organizations that are supposed to have military hygiene still do, but now they have other systems that make them shut down." So I am in Texas. Last week or the week before last, we lost our power, and that's because a nuclear facility shut down because of a single sensor getting frozen over. Now, you can't tell me that was done, that was something that they had put into their own cybersecurity, attack framework whenever it came to, hey, what's going on with our sensors? They hadn't even known that could actually happen if someone froze something. So basically what you're telling me is all I had to do is ever take a couple cans of liquid nitrogen, know exactly where to throw it into a lake or river, and I shut down an entire nuclear facility and thus hurt all these people with a lack of electricity because the grid starts shutting down very quickly and cascading dark, right? So those side channel attacks, that supply chain or side channel attack is really one of the things that we have to be the most concerned about when it comes to these sorts of things. That's what air gaps were there to prevent originally. Now, air gap is a physically disconnected system, an IT system unto itself, not connected to the internet or any other internetwork at all. Because everybody forgets the internet is just a bunch of networks connected, which is the reason why you call it internetwork and Bob's your uncle. So DNS and all that other, kind of holy war aside, there is that the internetworking piece becomes not a thing when it comes to air gapping environments. Now, we all know that that's almost silly now that I can actually hack a computer through its own video card and its microphone if it has its microphone turned on. I can do it from the screen and actually be able to see what's going on now using radio waves. So the air gap doesn't exist because radio frequency is what it is and computers are what they are, unless everything's in a Faraday cage, right? So which would be its own new air gap to bring it back again. Not everybody wants to exist inside a Faraday cage because everybody loves their cell phone, which is, again, the other way that everybody jumps the air gap. So, but I always thought that was pretty funny that everybody's so worried about everybody tracking them, and then they carry a cell phone with, some popular social media app on it. But that aside, the fact that we've all been hacked and compromised anyway is the death of the air gap. If you bring something like this, past that air gap, the air gap no longer exists. And thus there we are, because it's really about keeping interconnectedness away from each other. And it was supposed to be a physical control or mitigation for something that is the unknown unknowns when it comes to the cyber technical, the cyber side of the house. So that's your air gap. Unfortunately, it really never doesn't exist anymore because phones, and so there we are, and many other gadgets. So hopefully that answers your question. So
it does. So I think in our next video, we're going to be talking about more on the audit aspect and what we can report back from our findings on the detection that's occurred in Defender based on our architectural deployment.
And I'm very interested. Go ahead. Sorry. No, please. We're also going to get into a hunt too. I want to do a hunt with you and show you how to use it in hunting. So the audit compliance is something we could definitely touch on, what you can actually get out of it and definitely the signal. We'll definitely go through that as part of the hunt because you want to be able to split operations sometimes with cybersecurity. And that's really where the value comes into it. So we'll definitely cover that in the next round.
Check it out. And we'll be back with our next round shortly.